2x over 2x plus 3 is equal to negative
2x over
2x plus 3 is equal to negative 3 2x plus 3.
Oh, that's it? All right. You're like, man, that's all I need. Yes. All right. So there's kind of two ways to do this. We'll approach it the classic way. Are there any denominators that are not the same? They're the same. So what can I do? No, you don't need to. See, cross multiplication is a shortcut, and sometimes it makes the problem worse than it has to be. I don't need to cross multiply because what are these going to do? They're going to cancel the same way those did. They're not even there anymore, right? So if you cross multiply, that will work. You just made your problem look worse than it ever had to. Do you understand? So cross multiplication is a shortcut. If these ever have anything in common, and these are each other, so they do, cross multiplication will make it worse than it has to be. I like it. So almost every shortcut has some kind of a weakness, right? So here I can just multiply both sides by 2x plus 3 and it cancels. So I get
2x.
So then x equals
Negative 3 over 2.
what happened? So what do we do over here? Why did I draw that line through?
They cancel out.
Because I multiplied by it because they're all the same. So here, they're all the same. So I multiply by it so they cancel out. Same exact idea that I'm applying. I like it. The problem is, the answer is no solution. Why? The only answer we got, what does it do when I plug it in? Yeah, because if I solve this for 0, I get x equal negative 3 over 2. That's the one it can't be then, right? It can't be negative 3 over 2 because what does it do to my equation? It makes both sides undefined. Just to throw freaking in there. So then, therefore, there is no solution. Let me show you a slightly different way to do this. Do you know if they're already have the same? Can I just add this over? Do you see that? So if I have 2x over 2x plus 3, couldn't I just add that over? Simple, add that over. So I get 0 on this side. And what do I get? I get 2x plus 3 over 2x plus 3 equals 0. What's 2x plus 0 over 2x plus 3? 1 equals 0. What does that mean when you get that? No freaking solution. Yeah, there's a whole other way to get the answer. But math, there's normally more than 20 ways to solve something, but they all, at least at this level, they all have to agree. Yes?
Is this an example or a certain problem?
This was number, I don't
It
know.
was online problem.
Oh, it was an online problem. Okay.
Okay.
Gotcha. I wasn't sure where it came from. Sometimes it just comes from people's imagination. Yes?
I got a quick question. On 7.4, it's on my math lab. Number 15, this one right here. I got the questions right here.
Cool.
And then use the LCDs.
Oh yeah, there's one just like that in the...
The 180R. And the
Oh, okay.
180S.
Oh, so you're fine. It doesn't even ask you to do is okay. There's a problem in the book. For the people in the book, it had F and D and
No, number 15.
I know.
Not that one. Oh.
Yeah. Oh, you do have one with F and D in it.
Yeah, I got that one.
So yours, what does that one say again? No, I forgot. No, 1 over S plus.
Right here, number 15.
1 over, okay. All right, and real quick, all right, they tell you more, but how do I add those? Add those together for me. Add it. You get 2 over RS. That's my favorite answer. That's wrong. Of course it is. That's crazy. You can only add fractions where they have like denominators. And what's this guy missing? He's missing an R. He's missing S. Now they both. So now it's R plus S. Why can I not kill the SR? It's not an equation. It's just an expression sitting there. So I can't kill that bottom unless it's in an equation. So these two things. This is the same thing as this. Those are the same thing. That's not really an equation. In fact, sometimes you write 3 lines to say, this is not an equation to solve. This is a truth. It's like saying 2x plus 2 equals 2 times x plus... Yes, it does. X plus 1. It's a definition of distribution, right? All right. So your problem says if S equals blah and R equals blah, evaluate both of these. Well, what should you get if you evaluate both of them?
The same answer.
The same answer because they're supposed to be the same. That's all. You have to get the same answer for both because they are the same thing. I like it. So I don't know if you did it and it didn't come out. They should come out the same.
No, because see the way when you're working that out, they had to go down to the LCD where you had to figure out the LCD for 100 and 180, and then you had to break down 2.2 times 2 times 2 times 3
It made
times
it
5,
super complicated.
and you got to line up the columns and go as common as not.
Okay, so what did I say? S was what?
S equals 180 and R equals 100.
Okay, so let's take a look at this. So that would be 1 over 180 plus 1 over 100. I like it. So I don't know if you guys remember the way that I suggested you do these. And watch this. Let me see if you guys. The whole idea with the way I showed you how to do these when the numbers get kind of big. What's the biggest number they both have in common? 20. So you could start with 10. This is 18 times 10. This is 10 times 10. But then you see how these still have another 2 in common? So this is really 9 times 20 and 5 times 20. But now you can do it just like we did these other ones. You can say, who's missing what? Well, what's he missing that he's got? Yeah, that's all you got to do. Yeah. And of course, well, let's see what we get here. What is he missing?
5.
A 5. So you get 5, and this one's missing 9. 5 times 20 times 9 is 900. So you get 5 over 900 plus 9 over 900 is 14 over 900. I like it, which you can reduce. So what do you get when you plug it in here? What's R plus S?
180 plus 100.
Good, 280. And what's S times R?
100 times.
So it's 180 times, how many more zeros? 2 more zeros. Sorry. And if you reduce that, you'll get to whatever that reduces. They'll be the same. They have to be the same thing. They just will be the same thing. Is that cool? So I think, what's
well,
up?
No, I got that
Oh,
there,
sorry.
but because the answer actually is 748. Okay, I see what I did wrong.
All right. Oh, look at that. Crouching calculus, hidden math. I love it. This is calculus. Calculus. All right.
76 number 84 and 85.
All right, good. So here's the second thing from 7.6. I love it. You guys are like planted. If you need to borrow a calculator, we're going to do some calculator stuff right now.
Okay, the answer for that one was 7 over 450.
Yeah, because you just reduce this, divide by 2, divide by 2, to bam.
Gotcha.
And then that'll reduce all the way down. Okay. So please be sure to give these back to me. They're empty now, so hopefully you're near somebody, a nice person that will let you look on with them. And again, if you have an Android phone, you can't use the phone on any test, but you can certainly download that graphing calculator emulator that I have up there. You need to get Graph Calculator soon. Like I said, you can borrow it for $9 a month from that rentcalculators.org website. Yes.
I think you can also get it from the library.
Yes, you can check them out for I don't know how many days or whatever.
It's like a week.
Yeah? Okay, cool. That's pretty good. So do that 5 more times and you're through this summer. Right? All right. First thing I want to show you, let me start off with this interesting idea. Oh, space. Okay, cool. Okay. So So this problem, let's say 71, because I didn't assign that one. Alright. Oh, can somebody shut off one of the experiment? The one that shuts them off up here. No? Alright, turn the, there you go. Cool. What's your gut tell you? Now, I mean, 1 over x, very quickly. If x is 5, if x is 3, what's 1 over x? 1/3, I like it. If x is 1/2, what's 1 divided by 1/2? 1 divided by a half is 1 times 2, right? 1 divided by a half is 1 times the reciprocal of 1/2, 2, right? 1 cut in half, 1 cut by 1/2, that's weird. So 1/2, when I plug a 1/2 in, I get 2. Alright, that's all I want to say. So we haven't graphed 1 over x ever, I don't think. But this is what it would look like. When x gets really big, the answer gets really small. When x gets really small, the answer gets really big. That's why it looks like that. And then these are just the negatives. Same picture, just the negatives. I like it. Do you have to know all that? No, they gave it to me. And then here's y equals 4x. So the neat thing is, the thing I want you to realize about what we're going to talk about today is I can solve any equation in the universe by graphing both sides of the equation and seeing what? Where do you think the answers are to this equation? Because what's the equation say? 1 over x equals 4x. And where do they equal each other? Where they cross. So here's one answer. What would you estimate that to be? Half. Why do I not care about the y? What's the only variable in the equation? So I only care about the x value at the point. And what's the other answer? Negative 1/2. So there you go. 1/2, negative 1/2. The answers are there. Because I got the magic book with all the answers. Alright, so the idea there is if I graph both sides of an equation and look at them, the answer is where they meet. Whatever those look like, it's where they meet. That's neat. Any equation you've ever solved could have been solved that way. Alright, okay, maybe. So, then they give me problems like, let's do 83. Let me unfreeze. Sure. Look at that yumminess. So we see the answer sitting there staring us in the face. Alright, so if you don't have a book, write that down. It looks so yummy. You probably disagree with me. That's fine. Would you want to solve this by hand? No. Neither would I, to be honest. Actually, part of me wants to. So I guess I'm not being honest. But the beautiful thing is, there are equations that exist that are impossible to solve by hand. We have an entire realm of mathematics called numerical methods, which is just we figured out all these different ways of approximating the answers to these impossible equations that come out of something we're looking at. So we're looking at something, we're like predicting the weather. Oh, that's an impossible equation. Let's give it to the supercomputer to chunk and see what works. That's how they do the weather, isn't it? I don't know if you know that. Supercomputers just banging away at it. Alright. So everybody has that written down if you don't have a book? So let me switch over to the graph and calculator. If I can. Alright. So we clear away this parabola here. Go away. Alright, so let me just talk a little bit about the calculator, because I have a feeling that there are several people in this classroom that have never touched a button on the TI before. Is this true? Yes, okay. So let's talk about some basics. Hopefully you've used like a scientific calculator before, which is the kind of calculator where as you type stuff, they don't go away. Your basic calculator with the big old buttons and it's only got the 4 operations. You write 8 plus 9, the 8's gone. And you can only see 9. And you're like, did I write Prash? I don't remember shit. So the nice thing, very, very basic stuff. So, all right, let's all do this together. 7 minus 8 divided by 11. And I like it. So that, then now, what did the calculator do first?
Divide.
It's beautiful because the calculator knows order of operations. So what would I have to do if what I really wanted to do was 7 minus 8 over 11? If I really wanted to do this. 7 minus 8 over 11. Now hopefully nobody would have to do this in the calculator, but let's just get this idea. I have to write, yeah, exactly. So the calculator can only understand in a straight line. So if I write that, it's not going to be right. I got to tell it, oh, do this first. I like it. That's why a lot of us think division is last, but not every problem in the universe is like this. Division is not always last. Only if it was written like this, then division is last. Yeah, maybe. Okay. So then I would have to do parenthesis, 7 minus 8, parenthesis, divided by 11. All right. Oh no. Maybe. All right. Okay, cool. All right, so that's one thing. Now, watch this. It's kind of nifty. If I had to, square this, I don't have to retype this whole thing in. See this little above the negative key? It says A and S right there. Mm-hmm. So that button, it stands for answer, and it holds the last thing that shows up on the screen. It's in memory. So if I had to do that thing squared, it's going to square the last thing that was on the screen. Bam!
How'd you do that?
So let me do it. I'm sorry. Let me start over. Okay. So let me just start from the beginning. 7 minus 8 divided by 11. Let's all start there again. 7 minus 8 divided. So we all have that number sitting there. Mm-hmm. So now that number is in memory. A and S is how you access that memory. That little A and S button right here. See it right there? Mm-hmm. Let's just get it out of the way. Not A and S. It's A and S. Answer. I know what it sounds like. So then, if I wanted to, let's try taking the square root of it. Where's the square root button? Above x squared. They have all the square roots with the x squared because they kind of go together. So if I hit second x squared, so the second key is like shift key, to get to all the stuff that's above these buttons. So that's square root. Now some of you guys, how many of you guys don't have the parentheses shown up? You're lucky. The newer calculators, you still have to update this software on here. The square root button, the square root key symbol just gets bigger and bigger and bigger, which is nice. So if you have a newer calculator, so if you have a calculator where when you hit the square root button, the parentheses does not show up, that's cool. You can tell what's in the square root because you can just see what's in the square root. For me, I don't want to close a parenthesis until I get everything in there, and I just want one thing. I want that last answer. Now what's the bad's gonna happen to me, you think? Let's see what it does. Can I do the square root of that? No, yes? Alright, let's try it. Second, negative. So that's the square root of the last thing that was on the screen. That's what A and S means. Now look what it says. I love it. Why does it say this? Does somebody know?
Negative.
Because you can't take the square root of a negative number. You can, but it just doesn't come out real. I like it. Now what's really cool is when you get an error that says go to, this is not going to be very explanatory, but you go ahead and select go to, and it puts the cursor where the problem is. Of course, the problem is A and S is negative. So it's like, I don't know how to tell you that, dude. All right, maybe. Are you guys with me on the answer button? That's a very, very, very useful button to know. Now, what else is kind of cool? Let me clear that. If you hit second, enter. Do it a couple times. Second, enter. Second, enter. Second, enter. Second, enter. Second. What's it doing? Oh, look at that. That's just yummy. That's from, I think it's me. Yeah. What was that from? No, that's not me. It's somebody else. Second, enter. What's it doing? Yeah, it's going through because there's no scroll. It'd be awesome if they had a scroll bar. Now, some of you guys with the newer calculators, you just have to hit the up arrow. Second enter still does what it just did, but if you hit the up arrow, you can actually scroll back through the last things you've written. Because if you type this whole big thing in, 4 plus 7 times 4 minus 7 squared divided by 3, and you're like, oh shit, that was supposed to be a 2. and this giant thing. All you got to do is second enter, arrow over, replace the 3 with a 2. You're done, right? You guys understand that? Some simple editing stuff is that second enter, or just hit the up arrow if you have a newer calculator. Actually, I don't know. You can ask them in the Math Study Center. They were doing this last semester. They were actually, because you have a plug for your calculator, you can plug it into the computer and download the newest software for it. So then your square root button will grow instead of there being a, like when you do, where's, anybody know where the exponent key is? How do you do like 7 to the 4th power? Yeah, this is your to the button. There's your to the button. So if you do 7, caret, bam. 4, that would be 7 to the 4th power. I like it. I forgot what the point of that was, but there it is. You have to do to the some power. Alright. What else did I want to show you? I mean, there's just... I know that you all don't feel the same way about calculators. When I was a little kid, just to tell you a story about me, when I was like 7, somebody would come over to the house, like a financial person would come over and tell my dad, they would give me the calculator and I would just sit in the corner and just play with it. And it used to be all red numbers on there way long time ago. And I don't know what I did, to be honest, but I was fascinated. And that was a big sign about what Jeff was going to become. But you should just play. Look at this button here. Look at this button. It says math on it. Holy shit. Where's that button? Look at all that. There's a 3rd power. There's a cube root. There's changing things to fractions. Excuse me? Excuse me? So if I had 8.254 math, change it to a fraction, please. Right, you're like, why did I not know this existed like a year ago? Or 3 or whatever. Right. Okay, I like it. So this is why very often in some classes I'll say, I don't want to see your answer in reduced form because that means they got it right out of the calculator. Do you see what I'm saying? We want to do a probability or something else. Anyway, I just want to show you that. There's all kinds of shit on here. But let's focus on this. And again, the calculator Bible, the calculator instructions are up on the website. Don't forget that. And also, I'm a little disappointed. I don't know what it is. Oh yeah, I want to show you that too. I don't know if you guys are just opposed to the idea of doing a survey.
Sorry.
I had about 20 something people that have filled it out of 45. So I'm publicly shaming those of you who haven't done it. I didn't bring a list of your names, but just do that for me, please. Please do that for me. Because there is something really, really cool I want to show you related to some of the results from that, but I can't do that until I get some more data. All right, so what was I going to do? All right, here, calculator guide. So it talks a little bit about what I was talking about just a minute ago. It talks about the need to put parentheses in when you have a top and a bottom, so forth, so forth, so on. So graphing basics, I mean, this is a good thing to print out and have with you as you're doing homework. So let's come back to this. So if I want to graph an equation, so let's use this equation we have from this problem. You guys have it written down. So what was it? 1 over pi x minus 2. Remember that one we had that started this whole thing off? So I can go to y equals, and I can put in here equations that I want this to graph. So I'm going to let y1 be one side of the equation and y2 be the other side of the equation. And then I can tell it to graph it, and then I can just see where they meet. That's crazy. So if I put that in, how do I have to put this in though? I can't just do 1 divided by pi. I got to tell it that the bottom has got more stuff in it. So I got to do 1 divided by, parenthesis. Your pi button is right above your to the button. 1 divided by pi x, what was it? Minus 2. By the way, while I'm thinking about it, there's a... Someday I'll be able to do it right here. There's a minus button and there's a negative button. They do exactly what I just said, and if you use them in the wrong place, you'll get syntax errors. Minus button, negative button. Okay.
How do you get that mode again?
Sorry? Alright. Oh, good. Alright, let me start over. Is everybody here with all the Y's? Is everybody on the screen here? Is everybody here on the screen? Okay. Then you have 1 divided by parenthesis. Second, to get to the pi, your X button's right here. In fact, this is your general all-purpose variable button. Now, please, dear God, if anything weird is happening to you right now, if you don't have Y's, if you have R's, for example, maybe you're borrowing somebody's calculator and they have weird shit to it. Don't do what I'm about to do. So here. So it could look like this. Look at that shit. What the hell's that? I don't know. Actually, it's awesome stuff. This is related to like spirograph stuff where theta is the angle. Anyway, this means you're in the wrong mode. So like the mode, you want everything on the left highlighted. So if anything's not highlighted on the left, you go, oh, that's why it's all weird. I want to use funky functions here. There you go. Now we're back to Y. Thank God. So I'm assuming nobody's got weirdness like that. But that's why there's more than just X on this button, because it depends on what mode you're in. It's a different variable for that different mode. But this right now is my X button. So pi x minus 2. Yeah, how we doing? Are we all there? Plus square root of 2. Now watch this. This is where evilness happens for us with the older calculator. If you have the newer calculator where the square root button grows, you have to hit the over arrow to get out of the square root. If you have the older calculator where that parenthesis, I've got to close it. Or else everything after this is going to be inside that square root. What's the only thing I want inside that square root? The 2. So I better close it. So square root of 2 divided by parenthesis 2.1 x. Alright, that's the one side by itself. Guten Lorden. So you guys see how I had to use parentheses again to tell it that whole 2.1x is on the bottom. Alright, maybe. Okay. What's up?
My thing was kind of funky when I did the square.
Oh, does your square root just get bigger? Do you have a newer calculator? Oh yes, 2, and then you hit over to get out of the square. So if your parenthesis doesn't show up, don't put it in. The older calculators, they didn't realize that there was a way to write the software so it would just grow. Now they do. The square root just grows. When you do exponents, that was my reason earlier. When you do exponents with the newer calculators, the number actually goes up here in the exponent instead of having this to the. You just have to hit over arrow to get out of the exponent. Hit the over arrow to get out of the square root. I have to close the stupid parenthesis. Okay, maybe. Yes.
To get the pi sign, is that the pi sign? It's flashing like that. I don't see it.
You got your 2 then. Yeah.
Okay,
There's your pi.
Okay, that's big.
Second, but you didn't hit the second yet.
Gotcha.
Alright. So that's one side of the equation. Thank God the other side of the equation says what?
How do you get down there, Mom?
Sorry?
How do you get to the set Y2?
I hit enter or hit the down arrow. So the other side is 1.3. Okay, cool. I like it. So there's a lot of little things to worry about, and this is related to the fact that the calculator has no eyes. So I have to put parentheses in for the 4, dude. I have eyes. I can see a big division bar. Calculator can't do that. Maybe the TI 2000, you'll just point it at something and it'll do it. TI can do this. I don't want to. Screw you. We're taking over. Oh shit. Let's go ahead. Everybody hit. Does everybody have all that stuff put in there? What are we doing there? Randy, you are?
I'm trying to find the X.
Oh, there's your X button right there.
Oh, I know. Okay.
Next to alpha, yeah.
That's
Good. -2.
-2.
I think, yeah. Parentheses. Yeah.
Plug all that in, and it doesn't work like that.
Oh yeah, because your square root doesn't have parentheses. Oh, because the newer calculator also doesn't just. So you don't. So a couple things. You don't need parentheses. And see how all that's under the square root? Do you want it to be there? No. So you gotta hit the over arrow when you're done in the square root, and then you put divide by.
Question, sorry, how do I get from this point?
Oh, you need to do all this in there.
Thank you.
Yes.
From
Just that button's been hit so many times, it doesn't even say anything yet anymore. Alright.
Oh, no. I know what you mean.
Alright. I'm going to do this thing here. Alright, here we go. So if you hit the graph button, let's see what happens. Some of you guys are going to have errors. Some of you guys, it's not going to look like this.
Yeah. Not there.
What's your error say? Window range. Alright, cool. You sit on that. Oh, look at that. That's neat. Alright, I like it.
What is dim mismatch?
I like it. Alright. So real quick, any errors I missed? Yeah, somebody's got a window range error, a dim mismatch error.
I just have a scatter plot.
I got you. And somebody else had a scatter plot. I love it. I love it. You're like, I'm glad you like that shit, yeah. So, a couple things. Let me take care of the scatter plot issue first and the dim mismatch. That's both related to stats. So see how right above y equals it says stat plot?
Yeah.
So I want to hit second stat plot up there. And you see how somebody that has that issue there. Either like it's a scatter plot, like a bunch of points on the screen, or if it's a dim mismatch error. Turn all your plots off. And then those issues will go away. It's trying to plot data. Yours, there's no data, or there's not the same dimensions, so it's freaking out. So hit number 4.